my name is Maya Butani and I'm the third place winner of the NAVS Award at ISEF 2022. I was inspired to choose this project because both of my parents work with patients who either don't have healthy organs or they work with organ transplant. So as a direct result, I've learned a lot about the difficulties of living with unhealthy or damaged organs. So I've always had an acute awareness of what those challenges are like. The way that I came up with this idea specifically was a little bit random. Looking out in nature and looking at the world around me, I noticed how similar the structures of plant tissue seemed to native human tissue. For instance, the vasculature of spinach leaves reminded me of the diagrams of blood vessels that I had seen in anatomy textbooks. So I wondered how those similarities could be used. And ultimately, after doing some research, I realized that these similarities could be potentially used as a scaffold to help create healthy human tissues. My project is about using decellularized plant tissue as a scaffold for tissue engineering. Basically meaning I take this decellularized plant tissue and put human cells in it to grow a new, healthy human tissue, and to make these healthy human tissues more accessible for patients who need them. Ultimately, I learned that because of convergent evolution, the similarities between plant and human tissue are so great that there's actually advantages to using these plant-based materials as compared to other artificial scaffolds that are currently used for tissue engineering. In tissue engineering, the scaffold material is a material that you put human cells in to grow a healthy new tissue. And sometimes animal tissue is decellularized and used as that scaffold, or animal tissues are directly transplanted as that healthy tissue. But one of the difficulties with this is that the body does actually have an immune reaction to the proteins in animal matrices. However, these plant-derived matrices have different proteins and carbohydrates that aren't picked up by the human immune system, so you have less of an issue with immunosuppression and potential rejection. Another advantage of using these plant-based materials is that they're more accessible, and in terms of using these for an in vitro model, they would create a 3D model that would utilize native human cells that would actually create a more lifelike model of how cells would respond to different medications or treatments than current in vitro models. I am interested in lots of different scientific fields, so I'm really excited to go into college and explore different forms of research. However, this project has really instilled in me the value of accessible medicine, and that's something that I'd like to continue researching in the future. Ultimately, I'm really passionate about this project, so while I don't necessarily see myself continuing it immediately in the next few years, it's definitely something I could see myself coming back to. And I think the biggest thing that I've learned from this research and the biggest advice that I would give is that even when a problem seems really overwhelming or not manageable, when you break it down into its most basic elements, it oftentimes becomes a lot easier to approach and manage. So I guess my biggest advice would be to be patient and try to break down problems into the most basic elements. And by taking it one step at a time, a lot of times you'll find that really difficult or overwhelming problems become a lot more manageable. I'd like to thank this organization so much for supporting me and other young scientists like me in our pursuits of new innovations and new forms of research. Thank you.